Hello, quick video today on using SSH to authenticate to GitHub so that you can carry out Git operations like clone, push and pull without having to type in passwords. I'll start with a short overview of what we're going to do and why, and then show you how to use keys painlessly from Linux and macOS, and then how to do the same from Windows, which is just slightly trickier and not really quite as well documented on the internet. So, let's imagine Alice working on her laptop and she wants to clone one of her repositories from GitHub using the git clone command. GitHub needs to authenticate the user who is giving the command so that it knows who that person is and that they are authorized to access that repository. And the best way of doing this is via secure shell SSH communication. So Alice needs to create a public-private key pair. The public key can be shared with anyone, but Alice needs to keep the private key private because anyone who has it can pretend to be Alice in an SSH communication. Private keys are often protected with a password. When you generate the key pair, you provide a password. The key generator encrypts a private key with a password, and you can only use the key if you know the password. It's far too easy to leak a personal SSH key inadvertently, which is why people often protect them with a password or passphrase. So let's generate a key pair. I'm using Windows PowerShell for this part of the demo, but the commands are exactly the same whether you're using Windows, Linux or macOS. So first we create a .ssh directory under our user directory. On Linux or macOS you would go to the user home directory and create it there. Next we run the SSH keygen command, and this command is exactly the same in Windows, macOS and Linux, and it always defaults to creating the public and private key files in the .ssh directory. I've only used a very short password for this demo, but to keep an SSH key safe against brute force decryption, your passphrase should be at least 20 characters long. You can see two files in our .ssh directory. The first is the private key, the second is the public key with a .pub extension. Next, we have to add the public key to our GitHub account. Now the public key enables GitHub to construct a cipher challenge that can only be correctly decoded using the private key. So log into your GitHub account in a browser and then go to your profile settings, then SSH and GPG keys, and then add an SSH key. Give it a name to make it easy to identify. Now let's open a Git bash terminal and try some Git commands. Git bash is part of the Git install for Windows, and it gives you a Linux-like bash shell for executing commands. Although we are doing this on Windows, the commands here would work exactly the same in Linux, macOS and Windows. Git finds our private key in the default location, but it can't open it without the passphrase. We don't want to type this passphrase in every time we want to do a Git command, so let's take advantage of the SSH Agent. The agent stores a decrypted copy of your key in memory for other processes to use, so we only need to add the key when we start the agent. Most of the time you won't need to do this more than once a day. We start the agent using the eval command and the backticks because the SSH agent sets some environment variables so that commands like git know how to find the agent to get the key. Once the agent is running, we use the SSH add command to add our key to the agent. This is where we enter our password. Now, when we run git clone, the key can be retrieved from the agent and we don't have to enter the password again. There's one other thing to note. The first time you use SSH to connect to a server from a machine, you will very likely see a prompt warning you that the machine is not known and asking you if you want to trust its key. The server you connect to uses SSH to validate that you are who you say you are, and then SSH on your machine also wants to validate the server you are using. So the first time you are connecting, trust the host key and it will be saved in a known hosts file, also in your .ssh directory, so that you aren't prompted again. Now, Let's try using our SSH key from a Windows PowerShell prompt, not the git bash prompt. You could use git bash for all the git commands, but I like git to work for my Windows terminals and PowerShell terminals as well. Now the first time we try to clone from the Windows terminal, we get prompted for our password. Trying SSH add doesn't work yet either. Although Windows is using SSH Authentication 2, the way you set up the agent and identity is slightly different on Windows. The SSH agent actually runs as a Windows service, and there are a couple of other different bits of setup too. First, we need a PowerShell prompt with admin permissions. Then we try to start the SSH agent service, but we get an error message. By default on Windows, the service is disabled. So we set the startup type to automatic, so that the service is always started after a reboot. And now we can start the service too. Now the agent is running, we can set an environment variable so that other processes can find and use the agent. You need to provide a pointer to the ssh.exe command. Get command gives us all the information about the command, and the .source property provides its location. So this very long command sets environment variable git_ssh to the location of ssh.exe in the current user's profile. Maximizing this window lets us see it all on one line. Now let's start a new PowerShell prompt so that we pick up that new environment variable. Let's check it's set OK. Now we can run SSH add just like we did in the bash shell, and now git clone works just as it did before, and that's it. So what we just covered, we created an SSH key pair, same process whether you're using Windows, Linux or macOS. Then we added an identity using SSH Agent and SSH add, and that's slightly different between Linux and Windows. And then finally we cloned a repository to show that we're now being authenticated using the private key, and again that's the same whatever operating system you're using. Thank you for watching. Please press like and subscribe, and let me know whether you prefer technical how-to content like this or opinion pieces like the recent video I did on the history of waterfall and software development practices. Thank you for watching.